This is question 15 in exercise 20.1 in Project Maths 2. Given that the f of x is x squared plus 1 and the g of x is 3x plus 1, we have to solve for x, the f of x equals g of x, where x is an element of R. So what that means here is we're given two functions, the function f, which is just here, x squared plus 1, and the function g, which is just here, 3x plus 1. In order to solve for our equation f of x equals g of x, we're going to rewrite the equation, and in place of f of x we're going to write the function f, and in place of g of x we're going to write the function g. So if we write that out, we get x squared plus 1 equals 3x plus 1. And then we're going to solve this equation. Because we have a square in the equation, we have to move everything over to the left hand side of the equation, leaving just a 0 on the right in order to solve it. So when we move everything over, we get x squared minus 3x plus 1 minus 1 equals 0. And if we tidy that up, we get x squared minus 3x equals 0. Then from there what we can do is we can factorize out the left hand side. The highest common factor between x squared and 3x is x. And then in brackets we're going to have x minus 3. Because if we multiply this x outside here into this bracket, we'll get the term above back again. And now what we have is we have two things being multiplied together equal to 0. We have x and we have x minus 3. And if these two things multiply together to give 0, then either one or both of them equals 0. So for our sakes, we're going to say that they both are. So we say x equals 0, and we say x minus 3 is equal to 0. And if we solve this linear equation over here, we get x equals 3. So what these values mean is that if we put 0 into the f of x and the g of x, we get the same answer out. And if we put 3 into the f of x and the g of x, we get the same answer out. That's what we've solved in this particular situation. And that is that.